Hi everybody, big data, crypto, cybersecurity. This maths is based upon knowing the remainder from doing divisions. So this video is going to help understanding of why the divisibility rules are what they are, and we're going to do it from a modular arithmetic perspective. This will then give a far better chance to understand complex number theory and modulo in different bases, and maybe even identify values of digits in exponential numbers. So let's dive right in. In base 10, we've got a number 325. If we're going to divide by 10, we know there's no remainder in the tens. There's no remainder in the hundreds, etc., thousands, so we can ignore all of those. So what's the remainder? 5. So 325 is equivalent to 5 in modulo 10. That's how we say that statement there. How about when we choose to divide by 5? It's exactly the same setup. We know 5s go into tens and hundreds and everything beyond. So there's just this 5 units left over. So actually there's 0 remainder here. How about dividing by 2? Well, again, we know that 2 is a factor of 10, and so we've just got 5 lots of these here. So we've got no 2's remainder in the 10s and beyond, so we just need to look at the 5's. There's a cluster of 2, there's a 2, so we've got remainder 1. What about if we were going to divide by 8? Let's think about it. 1,000 in the thousands column dividing by 8. We know that makes 125 exactly. So what we're focused on is there's 0 remainder in the thousands and beyond, 10,000s, 100,000s, etc. So when we divide by 8, we only need to focus on the hundreds, tens, and units. How many remainders are there from 100? There's 4. How many remainders are there from 10? There are 2. How many remainders from 1? There, in the units, there's 1. So when we divide a number by 8, all we need to do is add up the remainders. We've got 4 lots of remainders from each 100, but we happen to have 2 of them here, so they cancel out. We've got 2 and 2 and 2 and 2. Those remainders cancel out from the tens. We've got another 2 remainders there and 3 remainders here, so we've got remainder 5. How about when we divide by 4? Well, let's look at the hundreds. 100 is divisible by 4 exactly, so we don't need to bother about the hundreds column at all. We only look at the tens and the units. So let's have a look at these tens and these units. So we can see that 2 of those remainders there cancel out and no remainder there. They cancel out there. We've got these 2 with those 2 there. So we've just got 253 is equivalent to 1 in modulo 4. What about dividing by 9? Well, we know that 1 divided by 9 is 1. 10 divided by 9 is 1. 100 divided by 9 is 1. What's 1,000 divided by 9? Well, I know that 999 is a multiple of 9, so this remainder is 1. So because there happens to be a remainder 1 in every single column, that is why there's a shortcut that we just add up the sum of the digits, because that's how many remainders there are in each of those digits. And I can see I've got 7 and 2 here, so that remainder is 0. So this remainder here ends up being 4. Exactly the same with dividing by 3. We just know 9 is divisible by 3, and so we know there's a remainder 1 everywhere as well. Because we had a remainder 4 with the 9s, one of the 3's goes into there, so we've got 1 left over. Bingo. So here's a little summary of what we've discussed here. Most of those divisibility rules and why they are how they are. How about dividing by 16? How about dividing by 6? What about dividing by some other prime numbers, 7, 11? We can leave that to you to try and investigate a bit further. One extra little challenge for you, a little game here. Here's 100 square that's just been coloured in a particular rainbow pattern. Choose 2 numbers. Ask your friend to do that. Don't tell you the numbers, just tell you the colours of the boxes that the numbers are in. Get them to add the numbers together or multiply them, it doesn't matter. And without giving the answer away, you tell them first what colour box their answer is going to be in. How's this connected to what we've just discussed, and why does it work? Hope you enjoyed that. Till next time. Bye bye.